Welcome to the Short Funk Podcast. I'm Tom Barbalet. Today, it's been a long time coming, but I felt at this stage that I really need to define this thing called Noble Ape. And I'm doing this in large part because a number of topics that I want to cover are so completely intertwined with Noble Ape that it's important that I give some definition of Noble Ape at this part of the recording. If your eyes glaze over through this period, please feel free to listen again tomorrow. No hard feelings here. Noble Ape was developed from a variety of different pieces of software that I had been working on for many years. I've talked about some of them already. But Noble Ape represented something very important to me. It represented a magnum opus. It represented a means of taking all these various bits of software that I had developed and put them together into something that I could show people, maybe to encourage them that I was someone who had some value, some worth. The software that I put together primarily related to landscape visualization and also agar simulation. Agar is the material that is put in petri dishes. Petri dishes are used to grow bacteria. So agar is a particularly nutritious medium for bacteria to grow in. And through simulating agar growth in bacteria, and I'm not really sure the origin of this development, I think it was just a combination of software experiments that I'd worked on, I realized that the communication that the bacteria had in the agar could be represented independently of the agar itself. This is a relatively abstract concept. It is the notion that the transitions of bacteria movement in this agar could be captured in a kind of delta form rather than just the agar growth itself. And the thing that interested me associated with how the agar grew, in particular the changes in the agar growth, was also that it could be a model used for communication. And here I mean fundamentally cognitive communication, not necessarily in the model of a neural network, but in something like that that could be used to convey the transfer of information between sensors, which just mean things like eyes, ears, touch, what have you, and actuators, which mean things that present movement. And this wasn't really a breakthrough at the time. But what I developed it into in Noble Ape has been the subject of some academic writing and some academic scholarship. And I think as it was distinctly different to the techniques that we used for neural networks, it is also part of the philosophical satire that I frequently return to. There's more than one way to think. So, on one side, you have a cognitive simulation that is based on this agar development, and on the other side, you have vast landscapes. And I love creating landscapes. I love creating electronic landscapes. I love creating narrative landscapes. A narrative landscape is a landscape where things have happened over time that cut into the landscape. It's almost like a story told over a landscape. And these kind of mathematics, this kind of analysis, the calculus that went into creating beautiful landscapes is something that really captivated me through my mid-teens. In addition to this, I had also written antiviral software, and the antiviral software was more associated with heuristic analysis, but also things that moved into compilers and interpreters, which is the stuff that I wrote after the antiviral software. Compilers and interpreters just took elements of the heuristic analysis and formalized them into something that would take user-written text and create executable code. It was amazing to me. It was the next wave of thinking which, transformed by ideas associated with programming, also was a nice to have, want to have, should have in the future with the initial Noble Ape development. It went on, in large part, to be ApeScript, which is the scripting language for Noble Ape. So, to start off with, simulated landscapes, simulated thinking, now there needed to be an underlying biology. And I took inspiration at the time from quantum mechanics, because the landscapes looked a lot like wave functions, which are the underlying elements of quantum mechanics, or wave functions. Through my study of quantum mechanics, something interested me very much, and that was the nature that through a wave function, you could create a variety of other elements through, taking the surface area, or taking the height at a particular point, or taking some calculus equation that was applied to the wave function would give you another property. So the biology of Noble Ape is very much associated with stacking these properties and creating entities through them. So, for example, mice may not like sunlight, direct sunlight, and they might not like salt, for example. But you can layer together these concepts of doesn't like this, likes this, doesn't like this, likes this, and then you have a formula for applying the landscape and working out the population density of a particular species. Now, with moving sunlight, you have the beauty that these populations can move. So obviously the plants are not affected by moving sunlight. They're affected by total sunlight. But the insects, the mice, the parrots, all the other kinds of creatures that are in the Noble Ape simulation are affected by moving sunlight, and they're affected by it in different ways. Also, as the moving sunlight interplays with other factors that affect them, things like surface area. So, for example, a tree might like a flat area more than a very steep area, or particular kinds of trees might like steep areas but not flat areas. All these kind of rules can be put in with quantum mechanics. It's very easy. This was the original Noble Ape simulation as it was launched. An agar simulation to create the cognitive processes, a landscape simulation, which ultimately started off with Fourier theory, but moved into fractals, and a biological simulation that created the biology that Noble Apes ate and interacted with on this simulated environment. That was the first release of Noble Ape. But what was interesting through this period was I had a wide variety of byproducts, and one of the main byproducts I had was actually the weather simulation. And the weather simulation existed from the earlier agar simulation. So the Noble Ape cognitive simulation is three-dimensional. You have agar information transfer in 3 dimensions. Not 2 dimensions, as with flat agar, but 3 dimensions. But I still had a 2-dimensional agar simulation that created these amazing kind of transference patterns and all these kind of strange deltas. So initially, I looked at that. I looked at using that to create the weather. And for probably the first 3 years, the agar simulation was what was the weather in Noble Ape. But then I realized something very interesting. Actually, the underlying formulae associated with fluids, compressible fluids, and non-compressible fluids enabled you to create a simulation that had water vapor, that had rain, that had thermal properties, and all these things were relatively simple, 2-dimensional with some additional 3-dimensional equations. At the time, mathematics was my language. At the time, studying physics, I had a very good understanding of mathematics, and in particular how certain things would interact. And when I created the weather simulation, something very curious happened. Meteorologists contacted me. This scared me at the time, because I was being contacted by people who seriously studied and simulated the weather. And they were looking at my ape simulation as a means of understanding or at least predicting certain elements of the weather. Now, truth be told, nothing within the Noble Ape simulation has ever reached academia in that light. There are no meteorological papers that are based on the Noble Ape simulation. But to get the respect from meteorologists when I had developed this idea, and to explain this idea, it is simple. You have a flat top, which is like the roof associated with the weather. You have an underlying landscape, and you push water vapor through this environment where it is squeezed in the top and releases rain. And this thing, self-maintaining, it's relatively non-chaotic. If you normalize with regards to the pressure, you can run this for tens of thousands of simulated years and have coherent weather over whatever landscape that you choose. It's very interesting. It captivated this group of meteorologists, but in no way was intended to be science. Curious, however, when you throw some numbers down, what actually happens. There is no way that I can capture the Noble Ape development in a single short funk recording. So what we're going to do is stop here, but there'll no doubt be future short funk recordings capturing various aspects of the Noble Ape simulation. Tom Barbley in San Jose, signing out.